Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 and our title is about shear strength in soil making. He is our group member Muhammad Shafiq bin Abdul Latif, Muhammad Nurilham bin Nordin, Nurhamizah binti Zaini, Aina Azwa binti Aminuddin, Siti Nurhaliza binti Fuad. And our lecturer is Dr. Aminuddin bin Muhammad Nur. RAP shear strength. Define shear strength, column and Morse model shear strength characteristic, shear strength testing. Okay, first of all, define shear strength. The strength of a material is the greatest stress it can sustain. The safety of any geotechnical structure is dependent on the strength of the soil. If the soil is filled, the structure founded on it can collapse. And the next is about shear strength in soil. The shear strength of a soil is resistant to shearing stresses. It is a measure of the soil resistant to deformation by continuous displacement of its individual soil particles. Shear strength in soil depends primarily on interaction between particles. Shear failure occurs when the stresses between the particles are such that they slide or roll past each other.
This is my part, shear failure of soil. So this is soil generally fail in shear. We have strip freezing and embankment. So the red line is failure surface. The arrow in red is mobilized shear resistance. Okay. At the failure, shear stress along the failure surface mobilized shear resistance reaches the shear strength. So this soil generally fail in shear. This gray color is retaining wall. This line is failure surface and the arrow is mobilized shear resistance. At failure, shear stress along the failure surface mobilized shear resistance reaches the shear strength. Okay, shear failure mechanism. Okay, in blue circle we can see failure surface. The soil grains slide over each other along the failure surface and no crushing of individual grains. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Azwa binti Aminuddin. My metric card number is AP190054. Today I will explain about Muhd model, Muhd failure criterion, and Muhd criterion limitation. Here is Muhd model. Muhd failure criterion. Definition: the variation of peak stress with confining pressure is known as criterion of failure. The simplest and best known criterion of failure is Muhd. Soil that have both frictional soil and cohesive can be combined into single formula, which can apply either effective stress or total stress analysis. Muhd criterion limitation. Muhd criterion is not particularly satisfactory criterion for rock. It implies that a major shear fracture occurs at peak strength. The criterion is likely to give incorrect result if the failure mechanism is not shear. It implies direction of shear failure, which does not agree with observation, particularly in brittle. It is linear, and peak strength envelope determined experimentally are usually nonlinear. Lastly, it will be noticed that only stress 1 and stress 3 are used and stress 2 is ignored in case of rock sample. That's all from me, and next will be continued by the next presenter.
Next is shear strength characteristic. For sand, firstly, saturated sand during dry shear. Excess pore pressure is 0 for saturated sands during the test. The shear strength of sands is derived vertically from sliding frictions between soil grains influenced by arrangement of soil particles. The soil grains are highly irregular in shape and have to be lifted over one another for sliding to occur, known as interlocking. The degree of interlocking will be greatest in the case of very dense, well-graded sands consisting of angular particles. In the case of loose sand, there is no significant particle interlocking to be overcome. Secondly is effect of void ratio and confining pressure on volume change. Loose sand having high initial void ratio tend to decrease in volume since they do not have any interlocking effect and permit closer particle movement during shear. Dense sands will low initial void ratio have high degree of interlocking. Dense sands under low confining pressures behave similar to loose sand under high confining pressure. Thirdly is characteristic of saturated sands during undrained shear. A sample of sand completely saturated is consolidated under an all-round pressure at a known initial void ratio. The sample is then sheared by keeping the drain valve open and applying the deviator stress at a slow rate. For residual soil, the quantity of contribution of the negative pore water pressure to the shear strength soil multi-stage consolidates drains strike shear test involve shearing under either a constant net confining pressure and varying metric suctions or under a constant metric suction and varying net confining pressure. An extended form of the Morph column equation was used to interpret the test result. Example involving stability analysis of the residual soil slope with varying pore water pressure profiles indicate that soil suction contributes significantly to the factor of safety, particularly for shallow slip surface.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Abdul Latif. My metric number is AP190174. Today, I'd like to continue my friend presentation about factors affecting shear strength. First is sand. The first factor is size of particles. Second factor is shape of the soil particles. Third factor is gradation. And fourth factors is pore water pressure. For residual soil, shear strength for residual soil is more higher than loose soil. Now we go to direct shear test. Objective is to determine shear strength parameters of the given soil sample by direct shear test. Equipment we needed to direct shear test is shear box carriage, loading pad, perforated plate, porous plate, returning plate, and lastly is weighing tools. Procedure is step 1 is weigh the weight of the sandy soil. Weight is recorded. Second, step up the shear box according to these steps. Step 3 is put retaining plate. Step 4 is put solid grid plate. Step 5 is test specimen. Step 6 is compact it. Step 7 is put solid grid plate. Step 8 is put porous plate. Step 9 is put loading pad. And 10, fix 2 halves of the shear box by means of fixing screws. Place the loading yoke on the loading pad and carefully lift the hanger onto the top of the loading yoke. Set the proving ring to 0. Set the monitor. Start the experiment until the machine stops automatically. Result recorded. Repeat all the steps by using different compressive stress. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.